I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this playlist, we have taken many questions based on trigonometric substitution. This particular video is using substitution of secant x. We need to integrate 1 over square root of x square minus a square. Now it is recommended that for these kinds of substitution, you should use x equals to a secant theta. Let us first try to understand why it should be done and how it really helps. And then we'll continue with the process of learning and understanding integration with trigonometric substitution. It is a very important topic for being successful and getting admission to best universities. Well, in case you want to learn from me, feel free to send an email on globalmathinstitute@gmail.com. Now let's try to understand the reasons of substitution and how do we really do it. So in the denominator, we have square root of x squared minus a squared. Recommended substitution is that x should be equal to a times secant theta. The reason is that if we do this substitution, then what happens in the denominator? We have x squared minus a squared. It could be written as a squared secant square theta minus a squared. So if I take a squared common, I get secant square theta minus 1. And what is that equal to? I hope you remember the trigonometric identity, which was 1 plus tan square theta equals to secant square theta. Now, if you rearrange taking 1 to the right hand side, you get secant square theta minus 1, and therefore what you get here is tan square theta. You understand? So that means that x square minus a square can be written as tan square theta, and that also means that I could now write the integral as dx over, since we have a square tan square theta, right, as equal to integral of dx over a tan theta. Do you understand? We have removed that square root thing, right? So this is for you to understand why we are doing so, right? One more step. Whenever you do a substitution, since we want only d theta, not dx there, so what should we do? Well, let's look into the substitution once again. X is equals to a secant theta. Now, if I take the derivative, then what do we get? We get dx equals to a derivative of secant theta is secant theta tan theta, right? D theta, correct? So taking derivative of the substitution, this is what we get. Now, if I replace dx with a secant theta tan theta d theta, then you can see that tan theta will cancel, a will cancel, and we'll get integral of secant theta, right? So that is the whole strategy of solving such questions. And that's the beauty of this substitution, x equals to a secant theta. So I hope you have understood this, right? So now let's begin with the solution for the question at hand, right? I hope that's absolutely clear. So once again, let's see how should we work with this, right? So clearly, if x square minus a square square root is in the denominator or wherever it is, the substitution recommended is clearly x equals to a secant theta, right? So we'll write x equals to a secant theta, and that means dx is a secant theta tan theta d theta, correct? Second part, x square minus a square will be equal to x square minus a square, or rather, I'll replace x with a square secant square theta, right? So a square secant square theta minus a square, which is a square common, secant square theta minus 1, and that is tan theta. So that is a square tan square theta, right? So now we are going to do all these substitution in the integral, right? So we can write down this expression as equal to integral of, instead of dx, I'll write a secant theta tan theta. I'll need more space here, so let me write down here. So we can write down this as equal to integral of dx is a secant theta tan theta d theta, correct? And the denominator is a square tan square theta, which gives us a tan theta. Clear? So square root will give us a tan theta, right? Now we can cancel a's and tan theta, so we get integral of secant theta d theta. Now integral of secant theta has been done in one of our videos. It's a standard formula now, and you can always use this, right? And therefore, we'll write down what is integral of secant theta. So that is equal to natural log absolute value of secant theta plus tan theta plus c, since this is indefinite integral, right? So I hope all this is absolutely clear, right? Now we need to write our results in terms of x and a, right? Since the question is in terms of x and a, right? That was the substitution. So what is secant theta? We have to write in terms of x over a, and tan theta also in terms of x over a, right? And then we'll get our real solution. So do not stop here while you are doing your solution to the question, right? It is midway only. Perfect. So I hope this part is clear. I'd like you to write these in terms of x and a now, right? Meanwhile, let me thank all the viewers and subscribers for watching my videos, providing us with excellent comments and suggestions. And you have been supporting us. That is great. For 15 plus years, we are providing you with absolutely free services. Almost daily, we are uploading new videos answering your questions. It is your channel support so that we can reach millions in remote areas where quality education is not available. Your support helps. So contribute as much as you can whenever you can. So now let's take this on a fresh page and solve further. So we got ln secant theta plus tan theta plus c as our solution. Part solution, I should say. So let me rewrite this as ln absolute value, of course, secant theta plus tan theta plus c, right? Now let's look into this substitution to write all the terms. So what we learned here was that substitution was, let me write down substitution here, x equals to a secant theta, correct? So secant theta equals to x over a. That means if this angle in a right angle triangle is theta, in that case, hypotenuse being x, adjacent side will be a, and the side opposite to it will be square root of x square minus a square. That you also see in the denominator, right? Do you see that? So that is a connection. That means you're doing absolutely right everything, right? And of course, if that is the case, Then what is tan theta? Well, tan theta is square root of x square minus a square over a, right? So that is what we need to substitute here. Is that clear to you? So let's rewrite our solution as ln secant theta is x over a plus tan theta, which is square root of x square minus a square over a plus c. Now a is common denominator, right? I could also write this as x plus square root of x square minus a square divided by a. And now we'll use the laws of logarithms to write the final answer, which is x plus square root of x square minus a square minus ln a, right, plus c. Is that clear to you? So that is how we are actually going to write down the solution. Perfect. It makes sense, right? So the idea is not just to get the answers. The idea is to how do we get to this solution? That is the journey of learning, and how we can apply it in related questions, because this is going to be just part of your question many times in competitive exams. Okay, so I hope that helps. Feel free to write a comment, share your views. If you really want to learn from me, send email to globalmathinstitute@gmail.com. We make difference. We can be part of your success story. Thanks a lot for your contributions and appreciation. Thank you.